folks, in part one, we created the environment. We created two networks. We put subnets in each network. We used peering to connect the networks. And we built two VMs in each network. So welcome to part two. In part two, what we're going to do is connect the environment that we built in part one to a local network.
Yep.
All right. So Ryan, it's all yours, bud.
Sure. So we have the resource group where the network sits in, and the way that you do this is you create a virtual network gateway in Azure. And so we need an endpoint to connect our VPN device on premises up into the cloud, and that's what this is actually going to serve the purpose of.
Right. Okay, so we're creating the virtual network gateway.
Yep.
All right, and so I guess at one end of this gateway, we have to have the environment that we built.
Mm-hmm.
Okay.
Yep. So we'll call this corp to south. This is the network that's actually being put into. It's defaulted to South Central, so I just went ahead and started there. So
that makes a lot of sense, and that actually is something that we should discuss, because we have two networks and they're in different regions. Doesn't mean necessarily. In fact, it means that we do it. It doesn't mean that we have to at all. We don't have to. We don't have to create separate VPNs to each network.
Correct.
We could create one VPN. Yeah. We just need an on-ramp that gets us into that environment.
Correct.
And so we could really pick either of the endpoints, right? We could pick east or south.
Correct. Yep.
Okay, just making sure that everybody understands that.
That's correct. So, and I'm going to do route-based. I don't have a VPN device is able to do some of the policy-based routing. So the policy-based also requires you kind of go up to different, different tiers of.
Yeah.
So I'm just going to go ahead and go route-based.
That's fine.
And this is actually where we talked earlier about the bandwidth. So I know I can't remember. I think this one is the one that's 1.5 gigabits. So these are going to be. This is actually landing in your subscription. For all intents and purposes, some virtual equipment that's highly available. So we won't see the VMs that are representing this under the covers in our subscription. But
you didn't. To be clear, you didn't create those. You didn't create VPN GW1. Those aren't pre-created by you. They're pre-created in Azure.
Correct. Yep. So these are different tiers, and depending on which one of those I pick, kind of dictates how large and capable of an appliance that we land in your subscription and attach to your network to be able to facilitate more connections. So one important thing, what we're going to do is a site-to-site tunnel, where you go from like your branch office into Azure. But we also, with these connections, support point to site. So if you have road warriors or salespeople that are out traveling the road, instead of them coming to a VPN concentrator on your network, you can actually have them connect to Azure and be able to access resources in the cloud. And then using that gateway transit option we talked about, they could technically use that as a pathway to get back on-prem too. Okay. So these tiers have different limits with a number of connections that they support and that sort of thing.
Yeah, so it's like selecting the size of the VM that you're going to build before you build it.
Correct, yeah.
Okay, so here's another question. Can I have two VPNs into the same environment? Let's say I want a link to site and a site to site.
Yep, so the VPN gateway that we're creating now will support both of those simultaneously.
Okay.
And you could, of course, create multiple IPsec tunnels as well. And then we have more sophisticated options that we support, like software-defined networks. So like, Cisco has solutions to make software-defined network connections in a mesh type topology using internet links instead of using MPLS. So that's kind of a more advanced topic, but we support that. That doesn't involve one of these, but that's another option where you can have multiple, for all intents and purposes, tunnels established from many branch offices or many office locations around the globe.
Yeah. Okay. So, great.
But this is kind of a simpler example. So, and this is where you can enable whether or not this actually is running in a highly available mode. So where we have active instances. So this basically will increase the SLA of this virtual network gateway that we're establishing in Azure. So obviously there's a cost implication there.
Yeah.
So I'm just going to leave that disabled for now.
More faster and more availability means more price.
Exactly. Yeah. Just like on-prem. I mean, you want to create a cluster, you got 2x the VMs. So the BGP ASN, I'll show you one that I've pre-created.
Yeah. So just
involves
make sure you're not showing anything that has a key or something like that somebody could use. But
sure.
yeah,
Yep.
go ahead.
Absolutely. Yeah. So I'm just going to go ahead and create this. So it does take a little bit of time to create.
Okay.
But while that's cooking, I can show you. So I already have one created that's connected, and I can kind of walk through, kind of what's involved in kind of making things work. So this is a network gateway that I've created, and you can see that when it gets created, one of the options in that wizard was what is a public IP address. So this is actually what I use on my router at home to actually point to Azure to tell it, what I want to connect to.
Okay.
And establish that IPsec tunnel. So when I go to configuration, I can see what tier I'm running at. With my gateway, you can see that I have the active mode disabled, so very basically identical to what I just did. I do have a the one we just created doesn't have BGP enabled. This one does. So what that's actually doing is allowing my VPN gateway in Azure to be able to broadcast routing information to my network at home and vice versa. So there's this exchange that occurs,
right?
That allows the networks to be known.
Right.
So I have.
So just so everybody understands how that works, right? So when you have multiple networks at home, your router learns about those networks because your router is likely connected to all of those networks. So it has those networks in the route. Right. So you wouldn't want something that you send from box A on network A to box B on network B to go out through your default gateway. You'd want it to go to the appropriate interface on the router that's connected directly to that network.
You got it.
And so BGP is just a way for us to advertise the networks that you can connect to over this particular link without going through your default gateway.
Correct. Yep.
Yep.
So we went with a 10-dot network. So this is actually, my network is actually 172.16.2.0 net.
And that's your home network, right?
That's actually the network in Azure. My network at home is 192.168. So you'll see that part in a second. This is still the configuring the because this network gateway, just like the one I just created, is in the south network that the diagram. So this one is of similar stature, that it's except it's actually just in a different location, but it's in a network that I established when I created it. So I think I might be able to see that here if I go to properties, public IP address. Somewhere in here, there's it's got to tell me what network it's actually part of. Right there. Skynet. So this is actually the virtual network that my VPN gateway is actually in.
Okay.
And it's in, you see, it's in North Central US. And when you create a VPN gateway, one of the requirements in Azure, when you use our built-in VPN appliance, is to have a subnet. Remember, we created the A subnet.
Yeah.
So there actually needs to be a special subnet for the virtual network gateway to be inside of, because we put this, we land some virtualized infrastructure into your network that you don't see other than that object I just showed you, the actual VPN gateway itself. So it needs a subnet to live on. And so this is a special subnet, and it gets created automatically. We'll see that when the other one gets finished. And so this is actually the my virtual network gateway. And you can see I don't actually see that there's an IP address, because this is actually an appliance that we manage for customers. And it creates this special subnet with the name, and the name is very important. is actually gateway subnet. So this is actually, and if I drill into that, actually, if I go back to subnets, I can actually see the subnets. So gate C, it's a /24. It's actually way bigger than it needs to be. I'm trying to remember the size. I think that you need a minimum of 5 IP addresses, if I'm not mistaken.
Yeah.
But it's oversized, but there are, and you can see that there's some IPs that are actually used internally by that VPN gateway. So that gets created for us by Azure.
Okay.
So if I go back to my gateway and go back to configurations, when you enable BGP, it actually sets up a BGP peer. So my router at home needs to talk to something in Azure to be able to exchange all that BGP details. So what happens when you enable that in Azure is that it will actually use typically the last IP in your subnet as that BGP peer address. So and it shows it to me. I can't change it. That's just as soon as you click that configure BGP, it does it.
But it's important to note that that's on the Azure side.
Yes, this is on the Azure side. This is not my network. Okay, so that that is an additional part of the configuration, and then the third part is to actually create the connection, because you have a VPN gateway in Azure, it can support connections to multiple endpoints. I could have a corporate office in Charlotte, a corporate office in Detroit, and both of them connecting to the same gateway.
Okay, so right now we've created the gateway, but we haven't really connected it to anything, correct?
Correct, and that's where the connections come into play.
Right. Okay.
And here's, so you see, I already have one, a Skynet to home, and we can just walk through the wizard briefly, and I'll go back and show how that works. So we'll just call it test, and it defaults, it's picking the gateway.
Yeah.
And then I need to tell it that it's, so you can create connections using a VPN gateway in Azure going VNet to VNet. So in that requirement I talked about earlier, where customers might need that traffic to be encrypted, going over that, you can actually use this to do that as an option.
So side to side IPsec, yeah.
Yep. So we're not going to do VNet to VNet. We're going to do the second one. And you can see that you also use these if you're using ExpressRoute. So that's why. So then,
because these are all just parameters that will apply to the connection type, right?
Correct. Yep.
A VPN gateway or ExpressRoute.
Yep. So now I need to connect to something, or I need to establish an association of the network on at home to Azure. And the way that's done is something that's called a local network gateway. And this actually is what establishes routing between the Azure network and my on-premises network. And I don't think it will, so it does actually show me one. So I'll go ahead and create a new one, and it's just so you can see how it works. I could say, Comcast home, and this is where I can put in my home network, .1.0/24. Oh, I'm sorry. Whoops. So this is, I'm sorry, I did that wrong. That goes down here. This is actually the IP address, the public IP address of my router. So this is, if I go to, what's myip.com, this is the address that Comcast assigns my router on the public side. That's what this IP address is.
Okay, that makes sense.
And then the second bit of information I need to give it is what is the range or ranges of networks that are on the on the other side of the network that you're attaching to. So that's why you need to create this local network gateway. So we have the virtual network gateway. That's actually the thing that we connect to publicly that actually acts as an interface, a VPN appliance. The local network gateway is a concept we have in Azure that establishes routing and details about the remote networks that we're connecting to. And if I go back to here, and this one I've already created, I call it Skynet on-prem Comcast, and you can see that's public IP from Comcast, and just the exact numbers I just showed you, except this is now actually actively running. So now I've told Azure what's going to be the address that's coming in and what my private network details are.
So that address space, to be clear, that's the address space that you have
This is at
in
home.
at home.
Yep.
Yeah.
Correct. Yep.
Okay. Yeah.
All right. So now we define that connection, and you see the state is connected. Now there's a bunch of steps that we can walk through on my router side that I need to connect up. Actually, let me finish going through the wizard here because I didn't actually finish that.
Yeah.
So if I go to IPsec, and I can pick, it looks like it'll let me pick that. It's going to give me a warning because it's already in use.
That's okay.
Yeah.
Do you want to share something else so that nobody sees your shared key, or do you care?
No, I'm not going to make. Because I can't reuse this because I already have the tunnel established on my side. So
Oh, okay. All right.
So I'm just going to go. So I'm going to walk through what you would do, and then we can go. Walk through.
Oh, okay. So this is just
Yeah.
going to be for demonstration purposes.
Exactly.
Okay.
So this is the key that would be used for, and this key is important because you need it on both sides. This is actually
right.
what was
Yeah.
used for
And
negotiation.
is there a minimum or maximum key length?
I don't know if it actually talks.
Okay.
Yeah, I'm not sure what the maximum is, but it looks like it's
pretty big.
Yeah. So
okay.
And then the final bit of details. Where is this? Well, actually, there's two bits of detail. What sort of IKE protocol you want to use for negotiation?
Yeah. So IP2.
Yeah, and then where it goes. All right. So if I go back, this is the one that's connected.
Yep.
And so if I go to shared key, that's actually the one that that would actually be my actual key, but I won't pull that up. But you can see that I've got IKE v2, BGP is enabled. So this is all of the stuff we just walked through. But this one's actually actively running.
Okay.
So now I'll kick over. I have a PF Sense, PF Sense, firewall router that I have running here at home. And I've got a couple of packages that I installed in this thing. One
okay,
is,
so to be clear, you need a piece of hardware to do this.
Correct. A piece of hardware or yes, actually you would. So like I know Ubiquiti makes some really nice devices that support IPsec tunnels. There's a lot of home routers that support point to site. So like if you're traveling and you want to punch in remotely, Asus and Linksys make some devices that support that.
Yeah.
But in terms of supporting IPsec tunnels, you do have to make sure that you have one that can support the IKE v2 and some of the SHA-256. You'll see that when I actually show you the IPsec parameters, that you need to be able to make sure that it can support those types of connections that are required from Azure.
Okay. So I think I actually went out and bought one of these after the last, when you and I talked about this, I went out and bought one, and it's sitting in a box downstairs. I haven't set it up yet, but I do own one. And it wasn't very expensive, by the way. I bought mine off of Amazon. It wasn't that big a deal.
And in fact, I think since you and I talked last, so I had a Ubiquiti one previously, and there's a technical reason, which actually might be worth even highlighting for anybody who has home networks, that the Ubiquiti device I went with, that you said isn't very expensive, and it does support connections over VPN. If you enable things like intrusion protection or an IP packet inspection, to be able to do more sophisticated introspection of the traffic going in and out of your router, with my connection from Comcast is 600 megabits, it was not able to keep up with that.
Okay.
So PF Sense is an open source. I'm using a community edition. I'm actually running one of these on a. It's actually pretty cool. I can pull it up real quick and just show you while we wait. Protect Belly. And they make these all kinds of different versions with different numbers of ports. These are a little bit more. These are much more costly, but they have lots of ports on them. Basically, they're Intel. Like these are quad core. CPUs with lots of. This one doesn't have any RAM or SSD. So like mine has a 32 gig NVMe drive in it, and it's got 8 gigs of RAM, and mine only has 2 ports. So I kind of went cheap, and I put PF Sense on it, and it can keep up with doing intrusion protection and some of the other capabilities that it has inbuilt without without even skipping a beat.
Okay.
You know, so I can see that we're actively on it right now, and the CPU is just kind of spiked a little bit, but it's yeah, there you go. It just spiked because I went to the screen.
Yeah.
But yeah, barely skipping a beat.
Okay.
So so IPsec. So what you do in here, and
And again,
so,
this isn't configuring Azure. I mean, everybody's probably already aware of that. But all we're doing here is configuring the piece of hardware
right,
that
exactly.
sits on your network that is going to connect to the Azure endpoint.
Yep. So there's my key, but it doesn't matter to me because this is just for demonstration purposes. So,
Right. Yeah.
so anyway,
that key might work for about 10 seconds today,
yeah,
but
exactly.
it'll be gone long before this video publishes.
Exactly. So now I need to actually define where am I going to establish this tunnel to. So this IP address, if I go back to the Azure screen and go back to my gateway, you see our other gateway is still creating. It takes a little bit of time to create. So this is the IP address 157.55.165.1. That is the IP address of my VPN gateway in Azure.
Okay.
And this is where some of the requirements come into play for being able to have a router that supports IPsec tunnels. You need to support different phase 1 and phase 2 encryption algorithms. So using AES 256, the SHA-256 hash, and then I have this DH group of 2, this 1024 bits. So that's the algorithm that I have enabled on my tunnel right now, and it's working fine.
Okay.
All right. So then once you do that, if I go back to tunnels, that now the phase 2 part of this, if I go in and edit it. So now this is actually, once the negotiations occurred with, over that IPsec tunnel, need to define all of the details of the remote network that I'm attaching to.
Okay.
And in my case, it's the network I was just showing you is a 172 network, and it's a 16, just like the one you and I just created with the 10 dot. So I just gave it the entire details of the address space, and enabled the AES and AES 128, and basically set everything else to auto to be able to make it negotiate.
Okay.
And hash algorithm. So these details are important because if you don't have these right, it's not going to be able to talk.
Right. It won't be able to negotiate an encryption algorithm.
You got it. So so that is the details of how you set it up. So then I can go to the status, and I can actually see that this is actually my connection. I named it Skynet, and you can see this is my Comcast IP, and this is the remote IP of my VPN gateway. And I can see that it's been up for 19,000 seconds, and it's it's actively communicating with with the VPN gateway in Azure, which is so it establishes a connection. When I go to connections here, that's what makes this flip to connected. So that now the two endpoints are talking.
Okay.
All right. So now I have I have a network in Azure, and actually if I go back to here, just like the one you and I just set up, this is my network. If I go to peerings, I have a couple of peers. You can see I have one in Europe, I have one in East, I have one in West, and one in South. So I've got connections from this network. So very similar to what you and I just did between East and South, but I have multiple networks enabled in Azure. But right now I have a VM that's sitting in this network, and I can see that if I go to connected devices, it'll show me all the stuff that's in here. And you can see this VM has an IP address of 172.16.0.4. So this is actually, and this is a VM running in North Central US. My network's in North Central US. My VPN gateway is in North Central US. So I just happen, everything's in that region at the moment.
Okay.
So with all of this in place, if all goes well, actually, let me just see, it looks like it's still running. So I'm just gonna go ahead and disconnect my remote desktop connection. All right, so if you can see this, you can see the IP address I have in here is that this is actually a VM, and what I'm going to do is just actually show you the VM just to make it really clear, because very similar to the Ubuntu machine that we just showed, except it's a Windows machine. I called it Cyber9 North.
Okay.
So it does have a public IP address, so I can hit it via that public IP address, but this is the private IP address, and it's,
Okay.
again, in that same network.
Okay.
So if all goes well, and I hit connect, boom.
There you go.
So I'm connecting to this machine from from my home network, if you're using its private IP address. And what should also work, and just to test it totally out, I should, from this machine, I can hit my pfSense. So now I'm in Azure.
There you go.
And I'm going back at home.
Yeah, that's cool.
Yep.
All right. So let's draw this out. Hang on just
Sure.
a second. So I want to be very clear about what we did here.
Yep.
So the endpoint was south, correct?
In my case, the one that you and I created was in the south. Now the one I already had set up was in the north, and the one in the south is still creating. We could walk through this.
Yeah, no, that's fine. That's fine.
Yep.
So we created a VPN gateway, right?
Yep.
Here. Okay.
Yep.
And then at home, oops, you have your pfSense.
Correct.
So right, and that's just a router that understands VPNs.
Correct.
All right. And then what we did was we connected that to the VPN gateway that we set up in Azure.
Yep.
Okay.
You got it.
And then behind the VPN sense, of course, is Ryan's network.
Correct.
At home. And we have proven that you can get from your network to the VMs we created in Azure, and we can get from those VMs that we created in Azure to machines on your network.
Correct. Yep.
Okay. Perfect. That's perfect. Okay. All right. So by the way, I see you're still in NORAD.
Yeah.
The only question I have
detected.
Yeah. The only thing that I have, the only question I have is, how are we going to get pop darts down to you?
It's a precarious situation out there.
I can get them from the moon to Earth. That's the easy part, right?
You just chuck them down. I mean, eventually, just put a parachute on them, and
yeah. I'll attach them to a bottle rocket, and at some point, it's going to get to, into the Earth's gravitational pull. It may take a while.
In fact, actually, that will toast it. So by the time
that's right. Here, yeah, during reentry, they will toast.
Yeah.
Maybe I could build a contraption that puts butter on them automatically as they heat because of the heat of reentry. That would be awesome. Yeah. All right. So Ryan, is there anything else you want to show us here about that?
No. I think that pretty much sums it up, and kind of showing network maybe 102 at this point. So.
All right, folks. Ryan, thank you again so much.
No
yeah,
problem.
I mean, this has really become more about this has really become more the Lex and Ryan show, especially when it's Azure, than anything else. But I'm going to continue to call it Taste of Premiere. So that's your Taste of Premiere.